Thank you. I'm Jerry Schwartz. I'm a CEO and one of the co-founders of Ecellix. We are a Seattle-based corporation commercializing technology developed out of Washington State University and some work at Pacific Northwest National Labs. And slide advance, please. Thank you. We find ourselves at a really interesting time. Lithium-ion batteries have undergone some evolution over time, but currently are inadequate for most of the needs that we're trying to evolve our marketplace in. Barely functional for electric vehicles. Certainly having my Apple Watch die after 10 hours and my cell phone need a recharge at 2 o'clock in the afternoon are not adequate use models. So there's a lot of attention being put into ways to enhance lithium-ion battery production. The quest for more capable battery has really gone in the initial focus. We've heard earlier about solid power and QuantumScape and others that are approaching a solid state and lithium metal approach. I think the general assumption is those are a little farther out. The acknowledged next wave is the silicon anode supporting current lithium-ion battery architecture. So the first wave of lithium-ion batteries came out in 1991. It featured graphite as the primary anode material. There's been research and a lot of investment for the last 13 years since 2008 in evolving to a silicon anode, but most of those have been revolving around a process of using nano engineering because of the notion that silicon expands 3.5 times when fully lithiated, and that causes cracking. And there's a general assumption that under 125 nanometers, you don't get the cracking performance. So a whole host of developers have gone that direction. And of course, a tremendous amount of money has been raised in the process. Where we're very different is that we start, rather than nano engineering building up with nano components from the ground up, we start with a large format silicon in the micron scale and do a etching process where we end up with a porous structure of silicon, pure silicon actually, 100% silicon, with a very thin carbon layer around it. This allows us to do a couple of things. First of all, our precursor materials are as much as 1% less than some vendors and up as high as 10%. So we start out with a very inexpensive metallurgical grade, 3N silicon melded with another metal to create a composite. That process is a two-step process, which is basically commodity materials utilizing a simple process that's very inexpensive. So it gives us a tremendous cost advantage while getting to a performance level that's equal or better to anything that others are doing, where silicon is the engaging opportunity. The thing about silicon is that it has 10x the electrochemical capacity of graphite. So there's a lot of capacity there if you can make it work. We're finding that our material tops out right now at about 7x, which is 2,500 milliamp hours per gram, compared to 372 for graphite. So there's a tremendous opportunity in making that evolution. Keep in mind that lithium-ion batteries for the last 30 years have improved in capacity about 1.5 to 2% per year based upon process improvement and some other aspects of it, but no monumental, quantum changes. This would reflect somewhere in the neighborhood of a 50% improvement. To put that into context, you're looking at storage capacity roughly 20 as much as 50%, just based upon what I was talking about. It also means that you can do a lot more with your batteries. If you look at the business case, is that you can do 30% less batteries, 30% less cells, with 30% reduction in volume, 30% volume weight. So those are all important things in really all form factors. Why the change right now? A couple of things. First of all, the California and a variety of other governmental institutions are mandating that we have to get over to a cleaner energy alternative. And lithium-ion batteries are really a cornerstone technology for making that happen for all types of, home storage application, cars, devices. Public sector funding, a lot of money being thrown at this space right now, and more on the way. Venture capital investment has spiked up dramatically. We've just closed our first VC round. And then the other thing is just global battery market. Right now, we're looking at 2024, $100 billion market for lithium-ion batteries, of which 25% of that is associated with the anode, and 15% of that total is anode material, which is what our market space is. Battery components, as I indicated, 15% is anode material. It's an addressable market of about $19.4 billion so in 2027. It's a large opportunity and a lot of players going after that. How we operate the e-cell material, as I said, is low cost. The other aspect.
30-second warning, okay?
Okay, great. Anyway, a low cost, simple process, which we provide to OEMs for multiple marketplaces, you can see. Have a very experienced staff, all industry veterans, about 7 ex-CEOs involved that are domain experts within their space. We have also, as other vendors have talked about, we have an advisory group that's Stellar, the head of the energy group at Argonne, the ex-chief battery chemist at GM, and others. We've been getting a lot of attention. We've won some awards. Of course, the timing here is that COVID hit in the middle and killed everything. And here's our timeline. We've just completed a relatively small round at 3.5. We're in a 10 million series seed round at the moment. Pilot manufacturing will be in place before the end of this year and commercial production next year. We will have evaluation cells out the end of this year and have broad participation and cooperation with a variety of industry players, Romeo Power in the commercial trucking space, working with Polaris Laboratories and some others that are on board. 5 key things to remember: our technology, because of its new approach, is swell tolerant. We have a cell structure that we actually swell into the cell instead of externally. Existing processes are leveraged. You can use current manufacturing capability with machinery. We have an exclusive license and patent in place, extensive leadership team, and a really large market opportunity. Thank you.
Thanks, Jerry. Opening up the floor for questions.
Hey, Jerry, this is Josh here from Ansi Partners.
Yes.
I get a little bit jaded when I see increases in 30 to 50% in battery capacity and energy densities.
Yep.
We see a lot of different types of battery technologies come through here. Like most recently, we've talked to companies like Nanograph, who are also doing silicon anodes, and that's like this technology is the end all be all in the battery world right now. What specific engineering challenges are you trying to solve as you move forward in the next year?
The biggest, of course, in the silicon space is cracking and SEI formation. And so those are things that always have to be optimized. A lot of that is the integration with the cathode technology and whatever electrolyte. There's Wildcat and others like that, make their living optimizing electrolyte to allow silicon to basically flourish. So I think that that's the biggest intersection right now for us is electrolyte development specific to optimizing what we do. In terms of those gains, first keep in mind that we're using 100% silicon. So many of the vendors are down in 15, 20, 30, 40%. And so their capacity is going to be less than what we're offering. Our test cells right now are 2,500 milliamp hours per gram. So we've got a lot of the energy, most of it unusable because of the cathode limitations.
And then what form factor are you guys operating with right now? Are you guys using coin cells? Or do you guys how you have cells?
Yeah, our samples that are going out in the fourth quarter are centimeter by centimeter single oil pouch cells. Okay. And we're doing pouch cells and coin cells, but the broad sampling, that'll be the format.
Go ahead, Dr. Grau.
Yeah, and we're collaborating people with a lot of experience. For example, Polaris Labs, that's doing some of our external engineering, has done over 40 silicon anode projects. So they've done bake-offs for various vendors. They've done, additive research for other competing vendors. Their indication to us so far is that the performance that we're experiencing and the characteristics that we're in the upper tier are best of class in really every category. For example, we're at 91% first cycle efficiency. The norm for silicon is probably about 86 to 87. So we're pushing on all the variables that make this an attractive commercial product at a really good price.
Have you been interacting with Doug Morris up there at Polaris?
Doug Morris, yes, absolutely.
I had a conversation with him yesterday. He's a good guy.
Yeah, he's a very good guy. Yeah, we're also collaborating with PNNL and with Argonne, and we've got a couple others in the bag as well as ongoing retained research with Washington State University, actually teasing into the interaction of these materials with solid state electrolyte.
Hi, Jerry, this is Diana Grauer with Technique FNC. You're raising 10 million. Tell me about your use of funds. What are you going to do with it? Are you going to scale manufacturing?
Sure.
Are you going to hire more people? Are you going to build stuff? What are you going to do?
All of that. We're just signing the lease for 12,000 square feet of combined office, lab, and production space. And that will host, starting Q1 of next year, building out LRIP capacity. So we're getting past pilot manufacturing into the ability to scale up for commercial, at least small commercial applications. So being able to fully build that out, it has a functioning state-of-the-art lab in the space already, so we're not investing in a new lab. It's fitting out a few specialty equipment, but the LRIP will be built from scratch. We are adding a couple of key engineering personnel as we progress ourselves from being focused on the materials characteristics and producibility of the material. The next level, we sit both in the domain of materials science and battery science. And we're boosting our capabilities in the battery science team dramatically with at least 2 senior hires and probably more, as well as we're doing a long-term contract with Polaris to provide a couple of additional dedicated headcount of senior scientists.
Go ahead, Judy.
Great, thanks, Jerry. What is your business model going to be?
Our business model of record right now is licensing, and it's primarily the notion that let's put it this way: if I'm going to walk into General Motors right now, we were founded in 2018, so we're a 3-year-old venture, and asking them to take a technology risk on a relatively small company, my chances of being successful on any scale other than a pilot are low. If I walk in with Showa Denka or Samsung or somebody like that, you do have the chances of making traction in those larger ventures. So we feel that some of these people will be the gateway to larger opportunities. That said, there's a lot of companies that would be interested in this type of material that have expressed that interest, that do not have the willingness or capability to go out and build anode materials. And we will have the capacity to do that, or have a partnership manufacturing capacity. So, but licensing is kind of the default, one, showing a willingness to do it, but also we're, going about, fully documenting our process, patent protection, trade secret, so that we can find some strategic partners that will be able to do that.